Hey everybody, Mr. Kowalczyk here. Today we are going to do our last lesson for Unit 6, which is quadrilaterals in the coordinate plane. That's going to be lesson 5. Now today's lesson is very similar to yesterday's lesson where we did triangles in the coordinate plane, except now we're dealing with four-sided figures. All right, so standard, I can use my knowledge of quadrilaterals, four-sided figures, to solve problems within the coordinate plane. So go ahead and pause that video and see if you can finish this opener on your own. You might need to go back to your quadrilateral family tree in order to look at what all of the clues in these three images mean. All right, hopefully you paused that video and tried it out. You got to do that. You got to stretch yourself and go back to your notes in order to help yourself. It's a great strategy to use as opposed to just waiting for me to give you the answers. All right, what type of quadrilaterals below? Well, first off, I see that I have two parallel sides. Remember, these arrows mean parallel. And over here, I have two congruent, because the straight lines here mean congruent, same distance. So if I have one set of opposite parallel sides, that tells me that I have a trapezoid. But more specifically, because now I know that I have a trapezoid, these are called the legs. And if the legs are congruent, then I have an isosceles trapezoid. All right, so isosceles means two congruent legs. And a trapezoid means one set of parallel sides. And a trapezoid, remember, we call those bases. Even though one's on the top and one's on the bottom, we call them bases. All right, letter B. What type of quadrilaterals below? Well, here I see that this is congruent to this, and those are opposite sides, and this is congruent to that. So when I have two sets, or two pair of congruent opposite sides, that tells me that I have a parallelogram. That's one of the properties of a parallelogram. All right, now finally for C, what do we have here? Well, we've got the same thing we had for B, where we have two pair of congruent opposite sides, but we also have 1, 2, 3, 4 right angles. So that's going to tell me it's a parallelogram, but if I go down from the parallelogram on my family tree, I have two choices. I have a rhombus or a square. Well, the rhombus, all four sides would have to be congruent, and that's not the case. Or sorry, I said rhombus or square. I meant rhombus or rectangle. Here, I have two sides that are congruent, opposite each other, and same thing here, but they're not all four sides congruent to each other. So therefore, this is going to be a rectangle. And it's a parallelogram with four right angles. Okay. Now, the main idea for today, just a reminder of how do we know what type of quadrilateral has been graphed? You got to remember these rules in order to solve for them in the next couple sample problems. So how do we know what type of quadrilateral has been graphed in our coordinate plane? Quadrilateral is four-sided figure. Now remember, we can be more specific as we move across, but quadrilateral is if we have a four-sided figure. That's it. Parallelogram, we have two pair of, and it can be either things what we're going to be looking for today. Parallel sides or congruent sides. So those are the things that we're going to be looking for to prove a parallelogram. A rhombus is four congruent sides. And a rectangle is going to be four right angles. A square has two things, four right angles and four congruent sides. kite is going to have two pair of congruents corresponding, consecutive. What's the image we use? Or the word we use, not the image? Adjacent. Adjacent sides. Remember, with a kite, we have adjacent sides right next to each other being congruent, and then we have other adjacent sides being congruent next to each other. They can't be the same length. A trapezoid has one pair of parallel sides. And then the isosceles trapezoid is what we talked about up above. It has one pair of parallel, remember that symbol means parallel sides, and one pair of congruent sides. Or let's use our trapezoid specific words: legs and bases. All right, now, using these rules, we are going to learn how to figure out what type of quadrilateral we're going to have graphed in the coordinate plane. First off, go ahead and take some notes. How do we do this? Remember, this is the step-by-step process. We need to find out whether sides are congruent, parallel, or perpendicular. Those are the three things that we need to find out about each of the sides. We use the Pythagorean theorem to find if the sides are congruent. And then we're going to use rise over run to find the slopes of all four sides. If any slopes are, remember, opposite reciprocals, like our example of -5/2 and 2 over +2/5, then those sides are perpendicular and you have a right angle. And then finally, if any slopes are equal, then those sides are parallel. All right, A through E is going to help us figure out what type of quadrilateral we have. Let's go for it. First, we use Pythagorean theorem to find the length of the four sides. Let's build our right triangles. A to B, B to A, C to D, and C to B. This is going to be 2, 1, 2, 3, 4, 5. This is going to be 1 here, up, and then 1, 2, 3, 4, 5, 6, 7, 8. Then we have 2, 1, 2, 3, 4, 5. And then we have 1, 1, 2, 3, 4, 5, 6, 7, 8. All right. So some of you are noticing that pattern already. So AB, right away, A to B is going to be the square root of 1 squared plus 8 squared, which equals the square root of 1 plus 64, which is equal to the square root of 65. BC, square root of 2 squared plus 5 squared equals the square root of 4 plus 25, which is the square root of 29. CD, same thing, 8 squared plus 1 squared equals the square root of 64 plus 1, which is equal to the square root of 65. So right away, I'm seeing that I have two congruent sides that match up with each other. And AD is going to be 2 by 5 is equal to the square root of 4 plus 25, which is the square root of 29. Awesome. So now we have two pair of matching sides. Okay, so then we know that AD is equal to, oh, that should be there. AD is equal to, goodness, AD is equal to BC. Lost my spot for a second there. BC, and AB is equal to CD. Okay, now we need to find the slopes with the rise and the run. That's why building our right triangles here really helps us out so we can see it, but we need to remember where our negatives are. So pay attention to that as you move from point to point in the quadrilateral. Okay, AB. So I'm going to go from A to B. So that means I'm going to go down 1, which is a negative, and to the left 8, which is also a negative. So I have -1 over -8, which simplifies to 1/8. And then B to C, I'm going to go from B to C. So I go up 5, which is positive, and to the left 2, which is negative. So up 5 and to the left 2, which is negative, and I can't simplify that. Then I go from C to D. I go up 1 and to the right 8, which is going to be positive 1/8. AD, so I'm going to go from A to D. That means I'm going to go up 5 and to the left 2, which is negative. So up 5 is positive and the left 2 is -2. All right, so now what I see is I have, are any slopes the same? So these are going to be parallel to each other, and these are going to be parallel to each other because they're equal to each other. So what that tells me is that I have 2 sets of opposite sides that match up lengthwise, and their slopes are equal to each other. And that's going to point me towards a parallelogram from my table. I also know, excuse me, that these are not opposite reciprocals of each other, obviously, because they're very different. Therefore, I don't have any right angles. So parallelogram is as specific as I can be. Yay. That's a happy person right there, because we have a parallelogram. Okay, last one for today, last problem. Let's check it out. We are going to now determine if 2 quadrilaterals are congruent to each other. If 2 quadrilaterals are congruent to each other. So how do we do that? Well, we're going to use a similar step-by-step process to what we used yesterday with our triangles. We use the Pythagorean theorem to find the lengths of all 8 sides. Because we have 4 sides in each quadrilateral, we want to determine if they are the same length. Compare the lengths of all 4 sides, all 4 corresponding or matching sides. If they are equal, then the sides are congruent. If the lengths are not equal, then the sides are not congruent. If all 4 sides are congruent, then you have 2 congruent quadrilaterals. I'll abbreviate that to quads. If all 3 sides are not congruent, then you do not have 2 congruent quadrilaterals. All right, let's get to it. So we're going to use the Pythagorean theorem to find the lengths of the 8 sides. Okay, so just like we did before, we're going to build our right triangles. 1, 2, 3, 4, 5 by 2. 1, 2, 3, 4, 5, 6, 7, 8 by 1. 1, 2, 3, 4, 5 by 2. 1, 2, 3, 4, 5, 6, 7, 8 by 1. All right. So AB goes from A to B. That's going to be square root of 1 squared plus 8 squared, which is equal to the square root of 65. BC goes from B to C. That's the square root of 2 squared plus 5 squared. That's going to be equal to the square root of 29. Zoom out a little here. CD is again 1 squared by 8 squared. Square root of 65. And DA is equal to the square root 2 squared plus 5 squared equals the square root of 29. Now, again, remember, we're not finding pairs of congruent sides in the same figure. We're comparing one figure to the other figure. Let me go ahead and do this. I will call this our green parallelogram. And we're comparing that, these lengths, to, we'll use, what color highlighter can I find here? An orange parallelogram. So now we're going to compare the lengths to this parallelogram and see if these lengths are their matching pairs between green and orange. So that's what we're trying to do here. See if I can find an orange marker. Oh, but I do have pink, and that's close enough. All right, so now let's build our triangles to do our Pythagorean theorem. I have 1 by 1, 2, 3, 4, 5. Now I have 1 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So the numbers are different, but I have to sort it out because they might combine to give me similar values to what I have over here. Now this is going to be 2 by 1, 2, 3, 4, 5. And then we have another 1 by, I can't assume it's the same as this. I have to count. I start here and I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is the same. All right, so now let's go ahead and sort these out with our Pythagorean theorem. First side is WX. So WX is going to be W here. This is a typo, so that should be WY. Sorry about that. So WY is 9 by 1. The square root of 1 squared plus 9 squared equals the square root of 1 plus 81, which is equal to the square root of 82. Now, square root of 82 does not match the side length of any of these sides over here. Therefore, they cannot be congruent shapes because I have to have something matching 82. Otherwise, it fails to work. So in this situation, we don't have any congruent sides. And we can say that, oh, this is a typo too. I should say 4. Apologies. Compare the lengths of the sides, circle the correct answer. If all 4 sides are congruent, then if all 4 sides are not, okay, then we do not have congruent quadrilaterals. So the cool thing about this is that as soon as we find one side that's not congruent by using the Pythagorean theorem, we don't have to move on. We can automatically prove to ourselves that we do not have congruent quadrilaterals. Okay. If you're the kind of person who likes to be a completionist, keep going, and I will solve the rest of these. Otherwise, have a great night, and we'll see you in class. XY goes from here to here. Square root of 5 plus 2 squared. That's going to equal the square root of 29 squared. YZ is the square root of 1 squared plus 9 squared, which is equal to, as we saw from above, the square root of 82. ZW is going to be 1 by 5. So that's the square root of 1 squared plus 5 squared equals the square root of 1 plus 25, which is equal to the square root of 26. So in this situation, oh, 29 squared, that's not right. That should be there, sorry. In this situation, we do have one congruent side, but that's just not enough in order for us to have congruent quadrilaterals. All 4 of the sides need to match up with each other. Awesome. Thanks for listening. Hope this was helpful and not too fast. All right. Have a great day.